protocol is how OmniServer knows what pattern of bytes to send to a device as a command or request. It also tells OmniServer how to interpret any data responses received from the device and what to do with that data, such as placing certain bytes into an item for your client to access. As you can see, there are quite a few sample protocols that install with OmniServer. These are helpful for getting a basic idea of what a protocol for a certain type of device might look like. These can be good to use as a start for a specific protocol for your device. Now, in order to create a protocol in OmniServer, it's necessary to have some form of documentation or details about the specific command structure needed to communicate with the device. Finding that information is the first step, and otherwise, without doing that, creating an OmniServer protocol is not going to be possible without that information. Now, this documentation is typically going to come in the form of the actual user's manual or a document specifically dedicated to communications with the device. It should have some section that explains what combination or pattern of bytes is used for a particular command, or what pattern the bytes of a response should be in, like what pattern that should look like. We're going to get started by taking a look at the sample modem protocol that's included here with OmniServer. This particular protocol is a basic example of a command and response protocol where we're sending some command to a device and we're expecting a response with some data back from the device. I'm going to look through the section and I'll explain each one in further detail. You see all the different sections here on the left-hand side. Let's start by taking a look at the protocol settings, which I access by just double-clicking. Now, here's where you define the protocol name, which is the name you're going to see in the protocol view, and that's also the name that you're going to select from the drop-down list when you're creating your topic. You can also give a protocol a meaningful description here, and if you'd like to define some copyrights, if this is a protocol you've developed from scratch, you can do so here. The maximum message length field basically defines the maximum number of bytes that a particular command or message can be and still be processed in an OmniServer protocol. For instance, if you had this field set to, let's say, 10 bytes, and you were to receive a response from a device that was 12 bytes, OmniServer wouldn't be able to successfully process that response because we've restricted it to a message length of 10 bytes only. Now, what I always recommend is setting this field to the maximum value, which is 32,768. And in version 2.6, we've actually made it so that this value is the default, which ensures that the message length is never going to be an issue for you. And 256 most times is long enough for a message length, but I've definitely ran into cases in the past where someone had a longer length on a message they were receiving, and that message wasn't long enough, so they were seeing some problems. So it's best just to max this out. The protocol enabled setting is true to its name. Toggling this setting enables or disables this protocol from being used for communications. We ignore intermediate rights to the same item setting. When it's enabled, this prevents OmniServer from sending out duplicate requests to a device. This prevents unnecessary traffic to the device, which can be good if you're worried about a whole lot of unnecessary activity. When it's disabled, OmniServer is going to send all requests to the device, even if it's a repeat of a previous command that hasn't completed yet. And it's recommended to keep this at the default of enabled, so that we do ignore those and we don't get a lot of repeat commands on the line. These are basically the major settings for now. The binary formats and the translations are a lot more advanced topic that we're going to cover in the second presentation in the OmniServer series, since those settings are less frequently needed for the majority of protocols that we see. I'm going to go ahead and close these settings. The next thing we see is our item list. Now, items can be considered as a means for a client to either pass data values to OmniServer for being sent to a device, or for OmniServer to process data values and send them to the client application. Items defined here are the items or the tags that you would use. You'd use this name to access these from your OPC GDE or SweetLink client application. It's best to define any items that you're going to need in your protocol prior to starting the configuration of your messages down here. Basically, just because you're going to need to specify those items when you're creating these messages, and you can't do that if they haven't been configured yet. So I mean, that raises the question: how do you know what items you need? Basically, when you're looking at your protocol document, you basically need to ask yourself two questions. One is what pieces of information, what values am I going to need to potentially pass from my client application to OmniServer or into my device? Basically, are there any sort of settings or parameters that I'm going to need to pass from my client application to OmniServer? Second question, what pieces of information or what values am I going to expect to receive from this device? Like what data am I trying to get from this device if I'm reading from it? How many different values am I going to have that I'm going to need to make available to my client application? So once you've answered these questions, you're going to know how many items you're going to need to configure. For example, if you know you're going to need to write 3 different settings or parameters to a device, then you'd need 3 different items, one for each of those settings. Now, if the device is going to be sending a response that's only going to contain, say, a single data value or a single piece of information, then you'd need a single item to handle that. All the items that you configure, whether they're for reading or writing, are all going to be listed in this items list here. We can add a new item by right-clicking on the item list, going to New, and selecting Item. Now, the item name is what, like I said, is what is used in the client to access that item. Also, again, an optional description can be defined here if you wish. The data type is important because that is the format of how the data will appear to a client application for that item. A discrete type item would basically be a Boolean value. It's going to have a value of 0 or 1. It's going to be true or false. An integer type would basically just be a whole number, negative or positive, but it's going to be a whole number. A real type would be a floating point decimal value. So if you know a value is going to be have decimal points after it, then you would use a real data type when you create your item. And a string type is going to be any ASCII string of characters. So say you've got numbers and letters together, that would be a string. The automatically activated setting here would activate an item even if a client application is not requesting it. This particular setting is rarely necessary when you're creating a protocol, unless you want it to automatically come up because it has some value, which we're going to get to the initial value shortly. If you had some value that you wanted it to possess as soon as it starts up. The read-only setting is exactly as it sounds. Enabling this setting means that no write from a client application to this item would be accepted or processed. You can only read values from client applications for an item that has this enabled. The echo output items value setting will copy a value that was written to an item by a client to the input buffer. The input buffer, that's where reads for an item from a client get their values. This is important if an item is meant only for writing a value to a device, but no read command is going to be sent to the device. That's going to bring back a value from the device for this item. This is basically going to keep the item from displaying no value in the client application. It's going to display the last value that was written from the client application because we copied that value. And the item as enabled setting does just that. When it's checked, this item will be available for client access, but will be unavailable if this is disabled. I mentioned the initial value section here. This makes it possible to enable an item to have a starting value prior to any client reads or writes for the item. If you enable this, you can put in a value here, and as soon as an application connects to access this item, before it reads or writes to the item, it's going to have whatever value you specify here, showing as the current value for that. Go ahead and close the item there. The next 3 configuration items we have here, the register what number list, topic variable list, and error detection code list, are really pretty advanced topics. we're just not going to have time to cover today, and they're not really used frequently. We are going to cover those in the next session for people who might have a need for those. We're going to cover the more advanced topics. I will give you a brief overview, though. A register number can be defined, and that register number is going to be used in conjunction with an item name. And it basically allows you to define a range, and when you associate that range with an item, it basically keeps you from having to create an item, to create multiple items. Let's say you go in here and you create a minimum and maximum range of 0 to 99. When you associate that with an item, that means you're going to have that item name with a 0, 1, 2, 3, 4, 5, and so on at the end of it. So you're basically creating 100 items, and you've only created a register number, and one item. But you've really created multiple items there. And that's what that's good for. It's really, really good. It makes it easier to define large numbers of items that are going to have sequential addresses. A good example of using registers is the Modbus RTU sample protocol that installs with OmniServer. It does make use of register numbers extensively. A topic variable, as I mentioned earlier, is a useful field for when a certain value or a parameter is going to change for different devices that use the same protocol. A good example of a parameter like that would be a device ID. That's included in a command or request to a device. Now, of course, you have multiple devices using this, then each device is going to have a different device ID. Now, if that needs to be included in any request that you send, and you had to hard code that number, then you'd have to have a separate protocol for each one of your devices. Topic variable prevents the need to do this. You define a topic variable and use that in the place of a hard-coded device ID, and then you get that topic variable in your topic whenever you define one for a particular device, and you just specify whatever that device ID is, or whatever other parameter that is there, which allows you to reuse the protocol. Okay, moving on to the error detection code list. Now, OmniServer has a fairly extensive, long list of existing error detection codes like checksums, LRCs, CRCs, for doing error checking on communications. What the error detection code list lets you do, let's go ahead and open that up here. It lets you define a custom error detection code. In case you've got a protocol that one of the existing error detection codes doesn't cover it, doesn't work with it, then you can go in here and you can specify these different parameters to match what your device documentation says the error detection code should be doing, what kind of calculation it should be performing. So that's what that lets you do. We'll cover that in greater detail next time. Now we're going to get to the meat of the protocol, which are the actual message definitions that define the data patterns that are going to be used by OmniServer when communicating. There's three different types of messages available on an OmniServer protocol. You've got host messages, which are used for communicating with devices using command and response, or just command-type protocols. You've got unsolicited messages, which are used solely for communication when no commands will be sent to a device, and OmniServer is supposed to wait for the device to just send the data message. And we have error messages, which are somewhat similar to unsolicited messages. You define these for receiving specific patterns of bytes that are defined for a device as errors. And this tells OmniServer how to handle when we receive those types of error messages and how to proceed. In the sample modal protocol, we have several host messages already configured. We'll go ahead and open the get PV host message, and I'll explain the different components here. We have the message name for a host message, and you have to give the message a name because all these are going to be displayed in your host message list over here. So it's usually a good idea to give it a somewhat meaningful name, because that's what you're going to see in the list, so that when you need to go in and make any changes to it, it's going to be easy to find that in the list. You can optionally give it a more descriptive title, since you don't want these message names to get really long. I'm going to go ahead and explain the difference between the two different types of host message. A read type host message is what you're going to use when a response is expected from a device when a command is sent. The request or command for this host message is going to be transmitted to OmniServer whenever a client is requesting at least one item, one data item that's specified in this response section of the message. So if you've got an item defined here that you're requesting, you're asking for a read for that item from your client, it's going to cause this request section to get sent out if you define this as a read type. Now, a write type host message is used when it's necessary to pass values from the client application into the request or command part of the message, into this request portion. Now, the request here is going to be transmitted whenever a client writes to an item that's defined in this section. So let's say you got an item defined here for a setting that you need to send to the device. Whenever you write that value to that tag, that's going to trigger this request to get sent. So that's what the difference between those two is. Also, it is possible to set up a trigger item for a host message, which is going to override either one of these two types. And we'll discuss that momentarily when we cover the change and trigger section. The notification item field is basically used to select an item that you've configured specifically for notifying your client application when this particular host message has completed successfully. Typically, you're going to want to use a discrete type item for this, and that item is going to toggle from 0 to 1 once this message is completed. If it's just a request, then it's going to complete as soon as the request is successfully transmitted. If it's a request and a response, it's going to be considered to be complete once the response has been successfully received. Now, this particular item, if you use this, is not going to automatically toggle back to 0, which means in order for it to be useful to you, you really have to write a 0 back to it from your client application, which means that the next time the message completes, it's going to go back to 1 again. Otherwise, it'll stay at 1 after it's incremented the first time. The message count item field, which is new in version 2.6, allows you to specify an integer item here that you've created in your protocol. Now that item is going to increment by 1 every time this host message completes. And that can be particularly useful for keeping track of how many instances of a command have completed successfully, or even as just an indicator that the message has completed, because the value is going to change every time the message completes. The automatically activating a host message tells OmniServer to go ahead and process the message immediately on startup prior to a client attempting reads or writes. This can be useful for sending initialization information to a device that needs to be sent out before you can communicate with it. Typically, though, this particular setting should remain disabled, though. Typically, your client item is going to be the only thing that you really want controlling reads and writes for your device, so you would want this unchecked. The Disable Unsolicited Messages setting, when enabled, tells OmniServer to process data received from the device by comparing it to response fields in those messages only. Normally, when this is disabled, OmniServer is going to compare received data to any response field in any message. It's going to compare it to received data to response fields in most messages. And it's also going to compare it to the received portions in unsolicited messages until it finds a match. And of course, the enabled setting is going to toggle whether the host message is available for processing or not. I want to go ahead and move to the request portion of a host message. This is where you define data that is to be sent to a device. Normally, it's just going to start as a blank space. Since we're already in an existing protocol, we already have a request defined here. Let's take a look at what we call the sequence builder, which is a way to create these particular sequences. Like if you notice, this is considered to be a sequence. These are hard-coded characters here. Each one would be technically considered to be a sequence. You're just hard-coding those characters. Those are the control characters, another sequence. We've got an error detection code that's defined here. We'll go ahead and take a look at how easy it is to use the sequence builder to add bytes to a request or even a response portion, because it's going to be the same. We're going to double-click in the blank space where we want to add additional bytes. So if I wanted to add something to the end of this, I'd double-click here at the end of it where the cursor is. If I wanted to add something here just after this STX, I'd position my cursor here, and double-click, and that's going to open the sequence builder, which allows us to configure this through the user interface rather than hard coding and typing into the field. The assignment section that we have here is used for defining what the actual byte or sequence of bytes that we're going to send is. This could be an item that a client would be writing a value to, or a hard-coded letter or number, or even a checksum, as I was just showing you. Most assignments are going to be single assignments, which means it's going to be in multiples of bytes. It's not going to be less than bytes like bits or nibbles or anything like that. Bit assignment is available if you need to access bits within bytes, and it does support up to 32 bits or 4 bytes per assignment. If we select this bit assignment as we have here, you notice we have all these unassigned assignments for all of these different bits. If we highlight one of these, we can go to the Change Assignment button over here. And let's say we had some Boolean items defined that we wanted to associate with specific bits that we needed to write settings to. You just associate a particular item with a bit. Say you had a 1-byte sequence and you needed to manipulate all 8 of those bytes, then you'd have a Boolean item defined for each one from 0 through 7 of the bytes. Now you're typically going to see this feature used, like I said, if you need to send status as bits within a byte, or if a device is sending you something like statuses as bits within a byte. This is going to allow you to handle those. As I mentioned, though, single assignment is far more common, so we're going to go ahead and switch back to a single assignment here. And if we click the Change Assignment button for a single assignment, it's going to bring up our sequence select menu here, giving us all of the options that we're going to be able to use to assign to this byte sequence. You see how we have our items here. This is going to display any items that we have on our items list that we configured over here, and allow us to select an item and insert that into our sequence for the data that we're going to send or receive from the device. Same thing to be said for the register numbers. If you have register numbers in this list, they're going to display here so that you can assign those in your actual message. We have a control section here that displays a list of all the different types of control characters that you might need to use in your message for a device. Like I showed you in STX over here earlier, that's considered to be a control character. Some common control characters, like I said, are start of text, end of text, carriage return, or line feed characters. Some of the more common characters. But this is how you would assign those using the using the sequence builder. The other section here, that's where you're going to find all of your predefined error detection codes, like your checksums, your CRCs, your LRCs. Additionally, in this section, if you have defined any topic variables or any custom error detection codes, those are all going to be displayed as whatever you called them, whatever name you gave them at the bottom of this list here. So that's where you would go to find those and assign those in your message. And the number section is where you can go. You see we have some hints here showing you what format to use here. If your protocol specifies that you need to have a decimal number at this particular point in the message, you just type the number in here. If it's hexadecimal, you do a 0x. If it's an octal format that your protocol documentation tells you, it would be a 0 and a lowercase o for an octal format. We're going to go back to our item section here. In order to explain the other formatting, advanced formatting sections, it's going to be easier if I go ahead and select an item here. So I'm going to go ahead and select our TV item. You'll notice that puts that in my single assignment for what I've selected for this particular sequence. We're going to go to the formatting section. Now this allows you to define the format of the raw data. In this request, that's going to be the raw data that we're sending over the physical line. In a response, that's going to be the raw data format that we're receiving in from the device. And there's so many options here that, unfortunately, there's way too many to cover each one in detail. Your protocol documentation should give you some sort of indication about what a particular format of a sequence should be, whether it needs to be binary data, opaque data. You get all these different all of these different formats here from the drop down that are really going to depend on what type of data you have. Like, if you know that for a particular sequence, like we're defining an item here, if you know for a particular item value that you're supposed to be getting from the device, if you know that's supposed to be real data, then if you want to assign a data type to it, it's probably going to be real normal, like for a decimal point type data, floating point. If it's not hex, if it's just decimal, it's going to be like a whole integer number, or it's going to be non-negative, then you use like an integer unsigned. We typically recommend just leaving this field at the default, because OmniServer is going to use the best data format based on what you've defined as the data type over here in the items list, because you've already told it what sort of data you're expecting. So typically you can just leave this at the default. The format size section down here is where you can specify a length for a particular sequence of bytes. For instance, if you've defined an item and you know the value for that item should be sent as sent, or you're going to receive this as four whole bytes from it, and your protocol document defines that as a 4-byte sequence, then you can define a length of 4 bytes here. Notice that adds that to my sequence up here at the top, so that's going to show you what formatting you've applied to it, what codes we're using to define those formats. If it's floating point, like we said, a real normal, notice we get a real, that's the format for a real normal. And if this particular device defines a specific number of decimal places after the decimal place, then you can specify those here. Let's say that there are 4 decimal places after. You see we get a length of 4 with 4 decimal places, and it's real data type. We're going to clear those out because we want to leave this at the default. And let's move on to the advanced formatting section. Most of these options are typically not used for most protocols. Some of these are fairly advanced. It really depends on the protocol. If the protocol is doing something really strange with its data and its ordering and things like that, then you might need to use these settings. This particular section here for the translation, that's where you would define whether or not this particular sequence should be translated. Remember in the protocol settings earlier we saw that there was a translation setting. This is where you tell a sequence whether or not to use any translations that you define there. Down here we also have multiple options for reversing the order of data to be sent out or received in different ways, such as reversing the order of a text string that it's sent out. That would just take completely reverse the order of those characters and how they get sent out, or how we expect them to be received. We can reverse bits within a byte, reverse nibbles within a byte, which would be 4 bits. We would reverse those 4-bit sections within a byte. We also have a setting here for plus sign on sign numerics, which is useful if the device expects a plus sign to be transmitted whenever a numeric value is non-negative. So if it's positive and the device expects there to be a plus sign, or it's sending as a plus sign, so that, and this setting is very useful in that case. You need to use that in order to process that. It's also possible to ignore leading spaces that might be used to pad variable length numbers. You'd see this if you have a sequence that has to be longer to accommodate possible larger values, but there are also small values that will be sent for that field that are going to get padded by spaces to account for the extra bytes. This setting is how you handle those additional pad space characters. And lastly, the order field is going to allow you to completely rearrange the order of this particular sequence of bytes that we're using here. For example, if this particular sequence was going to have 4 bytes, then if I type in here 1, 2, 3, 4, then we're going to process that as we would if that was empty. First byte gets sent first, second byte gets sent second, third byte gets sent third, so on and so forth. What this field allows me to do, let's say for instance, I go in here and put 3142. What that's going to do is tell OmniServer, hey, you need to send the third byte first, send the first byte second, and so on and so forth. You rarely ever see the need for this. I've only ever needed to use this once or twice for some crazy protocals where they decided they were going to really mix up the byte ordering on the bytes that were being sent and received. So we're going to go ahead and cancel out on that and close out the sequence builder for this request. Now you can also edit any existing sequences with the sequence builder by simply double-clicking inside any sequence. Like this LRC here, if I wanted to go in and change something about this, I just double-click on it, and boom, I add it in the sequence builder again. I can go to the formatting, change the formatting. Like if I find out that it needs to be 2 bytes instead of 1, I can change that. Any advanced formatting options I can change. We'll go ahead and close that for now. We're going to move on to the response section of our host message. The response portion of the host message is configured when you're expecting the device to send back a data response to this request that we've sent over here. It's important to note that if your device isn't going to be sending a response, let's say this is just a command that we're sending to it, there's no data that it needs to send back to us, so we're not going to get any response. Then you'd have this field will be completely blank in that case. The configuration of a response portion of a host message is really identical to what I just showed you with the request portion. You're going to be able to use the sequence builder to add byte sequences as needed. You're going to use that to make assignments of those sequences of bytes in the message in the right order that the device is going to be sending them. So if we go back over here, see we've got an ACK, an STX, and then we've got a PV, which is a command, an item, an end of text. Basically, we're telling OmniServer, hey, this device is going to send, the first byte's going to be an ACK, the next byte's going to be an STX, then we're going to have a P, then we're going to have a V, so on and so forth. We're basically going to compare every single byte we receive to every single byte that we have in here. So all this needs to match exactly. Now let's show that you can define items in the request that clients can pass values to for sending to the device. As you can see here, we have a TV item defined here in the response portion. And that's basically going to allow this item to receive whatever bytes the device has sent us that are in this part of the message, that are in this specific section of the message. Now, the TV item in here is placed just before this ETX control character, this end of text. As we can see, there's no formatting, there's no colon with a length like a 1 byte or a 2 byte, or string, or real. It's completely blank. We're using all the default formatting settings that I told you we recommend to start with. And since there's no length defined here, this is considered to be a variable length sequence. A variable length sequence means, hey, we don't know exactly how many bytes are going to need to be parsed into this item, so we're just going to leave that open. Basically, the only way it's possible to use a variable length sequence is if it's immediately followed by a fixed length sequence, like this hard-coded end of text character. Like that's hard-coded. We're telling OmniServer, at this point, this is definitely going to be an end of text character. This is always going to be here for this message. Otherwise, if this wasn't here, OmniServer wouldn't know when to stop putting data into this TV item. It wouldn't know when to stop. If we deleted all that, we wouldn't know when to stop. So that's very important. And as I mentioned, since we have an end of text character here after this variable length item, what that's telling OmniServer is to place all bytes that it receives after this equal sign into this item until it reaches this end of text character. So it's going to put any bytes or characters that it receives between these two characters in the actual message sequence. It's going to place them into this item. Now you may have also noticed we have an open square bracket here and a closed square bracket here at the end around this section in the response. These brackets aren't characters that are part of the message that would be sent or received in a request or response. So this is in a response. We've got this left square bracket here. The device isn't actually going to send us a byte to that left square bracket. In OmniServer, we consider these square brackets to be special characters that are used to define a segment of data that is to be used in calculating an error detection code, like this LRC at the end. That's going to be sent or received. In this response, the data received in a message that falls in the area between these brackets, starting with a P and ending with an ETX, all of this data is going to be used in calculating this LRC. This allows us to exclude these first characters, which is really common in protocols, that starting characters won't be included in an error detection code, things of that nature. This is how we handle that. Now, the value for an LRC or a CRC or anything, or any error detection code that's defined, the value that OmniServer calculates for that, with the values inside the square brackets, is going to be compared to the actual value that we receive from a device. And it must match it exactly for the message to be processed successfully. Okay, we're going to move on to the next section of the host message now, the change and trigger section. And this is the last section of the host message. This particular host message does not have a trigger point defined, as you can see here. What a trigger point is an item that you specifically define in your protocol that's going to be used to trigger the request portion of this host message and cause it to be transmitted out to the device. Typically, you're going to use a discrete item that you've configured specifically for use of this trigger point that you're going to select, even though it's going to give you the option of all items that you have configured. You're typically going to have configured an item specifically for this purpose that you're going to assign here. And basically, once you've assigned a trigger point here, whenever a client application writes to that trigger item, then this request and this message is going to get sent to the device. The message chain section is you basically use to chain together multiple host messages. As you can see for this particular host message, when a device response has been successfully received back for this response, then we're going to go ahead and we're going to process the stop underscore modem host message. Go ahead and process any requests and responses that are in that immediately after this one completes. Now, this is particularly useful for devices that require a lot of handshaking messaging, a lot of back and forth between OmniServer and the device for any given message, like a lot of ACKs and NACKs and confirmations that data was received. This is really useful for that. And one of the most important settings, and also it can be a dangerous setting if you're not careful, is the only activate message via trigger or message chain. This setting, when it's enabled, means that this host message will never be transmitted unless the assigned trigger or the chain here is true. You got to be careful using this because basically that means if this setting happened to be enabled and you didn't have any message chains or trigger points, then this host message would never ever get processed. You would want to enable this if you had a trigger point defined, and that was the only time you ever wanted the host message to get processed, though, which is actually typical when you're using trigger points. Most people use those specifically for that, so that the only time the message ever gets processed is when they trigger it. Now, the last setting here, when it's enabled, is only going to allow one occurrence of this request to be transmitted until a response is received successfully.